administered with alkaloid compound piperine. PLGA nanoparticle was designed to improve its solubility and stability. Anti-glycoprotein antibody may increase the bioavailability, which is high level of MDR attack resistant cancer cell. Few PLG nanosphere are also developed to encapsulate dimethyl curcumin and tested in breast cancer. Then liposome. Liposome formulation have resulted in improved treatment for drug-resistant tumor and reduced toxicity. Liposome are the particle consisting of one or more phospholipid bilayer and the structure somewhat similar to biological cell membrane. In polyethylene and polyethyl glycol formulation, we can exhibit 20-fold higher cytotoxic have as a drug delivery system. There are several nanocell are natural polymers such as chitin, chitron, and alginate are the most useful to preparation of nanogels drug delivery. Has been used as a system or treatment of skin cancer. A hybrid nanogel system accord to alginate, chitin, and using polycationic cross-linking method and tested at the HeLa cell. Solid lipid composition to oil in order emulsion. The size of solid lipid particle vary from 20 to 100 nanometer depending on the formulation and preparation method. Encapsulation of curcumin within the solid lipid nanoparticle increase in concentration and 39-fold increase the area under the curve compared to control powder curcumin in order. At the cyclic oligosaccharide, few studies have used cyclodextrin carries in curcumin delivery to enhance bioavailability, minimize degradation, and reduce nanoselective toxicity. As a result, it's improved bioavailability of curcumin and significantly reduced in tumor cell cell. I I would like to express my special thanks of gratitude of my HUD of our chemistry department, Dr. Harishankar Biswa, as well as the teacher, Dr. Lalitas, who gave me the golden opportunity to do this wonderful presentation on the topic chemistry of curcumin and drug delivery system of curcumin. I come to know about so many new things from this topic. Thank you, all of you.
Thank you, Jagannath. Next speaker is Shubhadeep Sengupta. Shubhadeep, are you ready?
Yes, ma'am.
Start your presentation.
I'm Shubhankar is presented. Hello, ma'am. Okay.
এখন কিছু দেখা যাচ্ছে না কিন্তু।
এক মিনিট। Ma'am, am I?
Okay. Make it full screen.
Good afternoon, everyone. I am Shubhadeep Sengupta. Today I will discuss about anti-cancer activity of curcumin. Cancer. One of the main cause of cancer is the loss of balance between cell proliferation and cell death. When the cell skip death due to the absence of the apoptosis signal, uncontrolled cell proliferation occurs, leading to different types of cancer. In vitro and In vivo studies, curcumin has shown very promising results in suppressing cancer cell growth and proliferation in several different types of cancer, such as prostate cancer, colorectal, breast, pancreatic, brain, head, and neck cancers. What comes next is a summary of the anti-cancer activity of curcumin and its derivatives in different types of cancer based on the data from in vitro studies in different cancer cell lines and animal studies. Prostate cancer. Curcumin has shown a strong ability to inhibit proliferation and induce apoptosis in prostate cancer, both in vitro and in vivo. A recent study has revealed the ability of curcumin to activate protein kinase, leading to attenuation of the oncogene signaling by beta catenin, consequent inhibition of prostate cancer. In addition to curcumin, some of its derivatives have also shown anti-cancer activity against prostate cancer. Metallocarcumin conjugated DNA complexes exhibited significant toxicity to prostate cancer cells. Colorectal cancer. Colorectal cancer comes third behind prostate cancer and lung cancer as the most common form of malignant cancer, although patients diagnosed with colorectal carcinoma undertake surgical removal of the tumor tissues along with chemotherapy. More than half of the patients suffer from relapses. In addition, curcumin treatment was able to down-regulate MID21 gene, which is what expressed in colorectal cancer cells by inhibiting AP1B binding to MID21 promoter. However, an in vivo study in mice with colorectal cancer demonstrated an improved response to radiation therapy when combined with curcumin due to its ability to target nuclear factor. Head and neck squamous cell carcinoma. Head and neck squamous cell carcinoma is the sixth most common form of cancer worldwide, with more than 30,000 diagnosed causes every year. In vivo studies of curcumin in different head and neck cancer cell lines have proven its ability to inhibit cell growth due to its effects on a number of cellular pathways involved in cell proliferation. Pancreatic cancer. The efficacy of curcumin in the treatment of pancreatic cancer was investigated in a non-randomized open-label phase 2 clinical trial conducted by Hilon et al. In this study, 25 patients with histologically confirmed pancreatic adenocarcinoma were treated with a combination of curcuminoids at a dose of 8 grams per day for 8 weeks. The patients did not receive any chemotherapy or radiotherapy for 4 weeks before commencing the trial and also during the trial.
Shubhadeep, move fast.
শোনা যাচ্ছে?
Yes, you are audible.
Brain cancer. The incidence rate of central nervous system tumors, including brain tumors, are predicted to increase by 6% between 2014 and 2035. Glioblastoma, which is the most common malignant brain cancer in humans, accounts for about 15% of all CNS tumors. In the treatment of brain tumors and GBA, surgical intervention and radiation therapy are limited due to infiltration of cancer cell into the healthy brain, leading to damaging effects after treatment. Therefore, alternative treatment using natural derived compounds such as curcumin with less side effects than the conventional treatments we are receiving, receiving more attention. Conclusion. Curcumin, the active ingredient of Curcuma longa extract, has been studied widely over the past few decades for its anti-inflammatory, antioxidant, anti-cancer, and anti-androgenic effects. Curcumin has shown considerable anti-cancer effects against several different types of cancers. Its efficacy and safety in cancer patients, either alone or in combination with other anti-cancer agents, has been proven in several clinical studies with human subjects. That's all. I would like to thank to my mentor and all other respected teachers in my department to help me to make this presentation. Thank you.
Thank you, Shubhadeep. Shubhadeep is my last mentee. Next, it shifts to the mentees of Horishadan sir.
Hello. So, the first presenter is Jasmine.
Yes, sir.
Kaji Jasmine Parveen. To share your PPT.
So my screen is visible.
Yeah, yes. Okay,
Okay.
continue.
Good afternoon to my respected teachers and my friends. Hello, I am Kaji Jasmine Parveen, a student of Surendranath College, Chemistry Department, Sempur. Today I am going to present my review topic entitled Organic Ammonium Tribromides in Organic Synthesis. My first point is bromination of aromatic compounds. In organic chemistry, electrophilic aromatic bromination is an important and fundamental reaction. We can say that the aromatic compounds react by electrophilic aromatic substitution reactions in which the aromaticity of the ring is preserved. Even many fundamental groups can be added to aromatic compounds via electrophilic aromatic substitution reaction. Here, as an example, is described that the benzene reacts with bromine to form bromobenzene. In this reaction, the electrophile means bromine forms a sigma bond to benzene ring and yielding an intermediate. Then a proton is removed from the intermediate to form a substituted benzene ring. Next, importance of bromination reaction. In today's chemical industry, the bromination reactions are crucial and the versatility of the organotribomides makes them suitable building blocks for numerous syntheses. Even the highly reactive and toxic molecular bromine really makes the bromination hazardous. In organic chemistry, electrophilic aromatic bromination is also important. Besides, the use of bromine is like water purifier and brominated compounds are used for water treatment in swimming pools to control algae and also for the bacterial growth in industrial process. Next, the method for the bromination of aromatic compounds. Bromination is achieved with the help of Lewis acid catalyst as it polarizes the bromine-bromine bond, and the polarization causes the bromine atoms within the bromine-bromine bond to become more electrophilic. The methods for the bromination of aromatic compound according to this point is that aromatic compound is a deactivated benzoate compound, and also the temperature of the reaction ranges between will be minus 10 degrees centigrade to 30 degrees centigrade, and the brominated agent is added to the aromatic compound dropwise. Next, liquid bromine. We know that bromine is the third lightest halogen and is a fumic red-brown liquid at room temperature that evaporates readily to form a similarly colored vapor. And it is used for many areas such as agricultural chemicals, pharmaceuticals, chemical intermediates, insecticides, and besides, bromine compound can be used as flame retardants. But there are many problems for the using of liquid bromine, like skin irritations and burns, severe digestive tract burns, headache, vomiting, abdominal pain, possibility of death also. For inhale, it may lead to chemical pneumonitis and pulmonary edema. And now, how to solve this problem? As bromine is very toxic, corrosive, and dangerous for the environment, it is important to wear protective equipment and follow appropriate guidance when handling liquid bromine. So, it is very important to wear heavy duty chemically resistant gloves like nitrile and also not to use disposable plastic gloves. And second one, the wear eye protection like face shield or goggles. And last, at the time of working with liquid bromine, it should be conducted in a fume hood unless other controls are designated in the protocol. Next, all about organic ammonium tribomide. Organic ammonium tribomides are attractive solid bromineless brominating agents, and it is mainly easy in storage, transportation, handling, and also for the of the desired stoichiometry also. But it is used for many types of things, that is papers and films, photographing plates, in pharmaceutical preparation, in corrosion inhibitors, and it is also active for very types of biological activity like anti-tumor, antibacterial, antineoplastic, and antioxidant agents. Here, several examples of organic tribomides are tetramethylammonium tribomide, cetyl trimethylammonium tribomide, phenyl trimethylammonium tribomide, and the last tetrabutyl ammonium tribomide. Then bromination of aromatic compounds with EBMIDTB. EBMIDTB means ethylene based N-methylimidazolium ditribomide, and it is prepared from N-methylimidazole and 1,2-triboroethane and bromine, and it is used for the bromination of aromatic compounds. First of all, phenol is chosen is a model substrate here, and it is treated with EBMIDTB at room temperature in dichloromethane. After 30 minutes later, it forms the parabromophenols and the yield is 95%. And from this table, we can see that phenol methyl substituted phenols and beta naphthol are reacted with EBMIDTB in room temperature and also providing parabromophenols after 30 minutes. And the last other hand, the electron withdrawing substituted phenols were applied in this reaction. Then the monobrominated isomers are obtained. Next, the bromination of selected substrate by tetrabutyl ammonium tribomides. Here in this reaction, you can see that vanadium pentoxide is dissolved with hydrogen peroxide and is triaring at 5 degrees centigrade, and then you get a clear red solution of tetrabutyl ammonium tribomide in at ambient temperature. And then the reaction took place, and we get yellow or orange color participation of tetrabutyl ammonium tribomide, and after that the product is isolated 15 to 20 minutes and dried in air 2 to 3 times in air. And from this table, here it is described the bromination of aromatic and some other substrates with tetrabutyl ammonium tribomide. And here the aniline very smoothly to give bromoaniline, and also the parabromo and 2,4,6 tribomoaniline may be selectively synthesized depending on the molar ratio of the reagent. And also the polycyclic aromatics such as anathracene and phenanthrene can be brominated in acetic acid also. So as conclusion, we can say that organic ammonium tribomides, which is used as an alternative sources of bromine for bromination reactions, and even it is safe to handle in laboratory than liquid bromine. Besides, it brominates various aromatic compounds with a regioselective manner. At the last of my words, I want to say that I'm thankful to my department to give me this golden opportunity and to present my review article in this student seminar. And I want to say a special thanks and gratitude for my mentor, Dr. Horishadan Ghosh sir, for giving me this review topic. Thank you to everyone.
Okay, the next speaker is Kaushik Bhagat. Kaushik?
Yes, sir.
Yeah.
Sir, I'm audible?
Yeah, you are audible. Please share your screen.
My screen is visible, sir?
Yeah. Make it full screen and start presentation. Okay, start.
Hello. I am Kausibar, student of SEM 4 from the Department of Chemistry, Surendranath College, and I am here to present my review topic entitled Use of 1,3-dibromo 5,5-dimethyl hydrogen 20 in short DBTMH in organic synthesis. Now, let us see first what is DBTMH or what kind of compound is it. No doubt it is an organic compound. And there is a special class of heterocyclic compound called hydrogen 12, and this is the 5,5 dimethyl derivative of hydrogen 12. Now, DBDMH actually is N-bromo derivative of 5,5 dimethyl hydrogen 12. That's why it is called dibromo dimethyl hydrogen. Now, as the physical properties, it has the appearance of white crystalline solid with its bromine-like order. Now, as a brominating agent, we are well aware of two common brominating agents. One is molecular bromine and another one is NPS. Now the question arises why we are bothered about a new brominating agent called DBTMH apart from molecular bromine or NPS. The answer is molecular bromine is actually corrosive, so it is very hard to handle it in laboratory. On the other hand, DBTMH is very safe to handle or use in laboratory, and NBS is the source of only one bromine equivalent, whereas DBTMH is actually the source of two bromine equivalents. That's why it is more effective in the reactions. Now the question is, where from we get DBTMH? Unfortunately, there is no natural source of DBTMH, so we have to synthesize it. Now, before the DBTMH synthesis, let us first see where from we get hydrogen 2. As then just brominate the dimethyl hydrogen 2 and we get DBTMH. Dimethyl hydrogen can be synthesized from glycolic acid and urea. After synthesizing dimethyl hydrogen 2, just by brominating the nitrogen centers of 5,5-dimethyl hydrogen, we get DBTMH. This reaction actually similar to this reaction where succinimide can be brominated to N-bromosuccinimide. A noteworthy point is here that hydrogen was first isolated by Adolf von Baeyer in 1861 during his studies of uric acid. Now the synthetic applications. The use of DBTMH in organic synthesis is well developed nowadays, and its use in different class of reactions is excellently published in different journals. In some reactions, it acts as a catalyst, and in some reactions, it acts as a reagent. To discuss all the applications is beyond of my scope. However, I have cited here some reactions point-wise that are briefly discussed in my review paper. Apart from the synthetic use, DBTMH is nowadays used as a disinfectant and biocide products. Now let us see one by one the reactions. The first one is as a catalyst to improve the reactivity of carbonyls. To exemplify this, I have chosen the esterification reaction, and which obviously involves the carbonyl moiety for the reaction. Now, for the esterification reaction, we commonly use an acid to catalyze the reaction. Now, here we have now to carry out this reaction, different catalysts like NCS, NBS, NIS, DCDMH, DBTMH, DIDMH was used, and after this comparative study, DBTMH has been shown to be most effective here. A point to be noted that no conversion was seen in absence of any catalyst. Actually, all the catalysts can provide halonium ion, that is X plus, in the reaction medium, which is responsible for the catalytic activity. Now the second one is benzylene versus aromatic bromylation. Let us come to the second. What we are actually trying to do here is to brominate benzylic position and aromatic ring selectively in a benzylic system like toluene here. An amazing fact is that if we use molecular bromine, If you use molecular bromine, then we get only aromatic bromination product. And if you use the DBTMS, then we can selectively get aromatic bromination product and benzylic bromination product. That is what I have cited here, that if you use zirconium chloride as a catalyst with DBTMS, then we get benzylic bromination product. And if you uh, use Bronsted acid like trifluoromethane sulfonamide, then we get aromatic brominated product. The third one is oxidation of benzylic alcohols. Benzylic alcohols can also be selectively oxidized to aldehydes and esters just by changing the reaction condition. That is, if we use benzylic alcohol and DBTMH in 1:2 ratio, then we get 50% methyl benzoate and 50% benzaldehyde. On the other hand, if we use the same in 1:4 ratio, then we get 98% methyl benzoate. And if we reverse the ratio, then we get exclusively the benzaldehyde. However, this selective oxidation is impossible with other oxidizing agents like molecular oxygen or metal oxides, etc. Now, the fourth one is the conversion of gamma-gamma dicarbonyl substitute aldehydes to gamma-lactam. This is the gamma-gamma dicarbonyl substitute aldehyde, and this is the gamma-lactam. And this is the reaction condition where DBTMH acts as a catalyst, where NaClO2 acts as an oxidizing agent, and it is the halogen radical which is actually responsible for the catalytic activity. To understand the reaction properly, it requires a large discussion. So I'm not going into deep here. However, I have cited a comparative study where different source of halogen radical has been used, and DBTM is shown to be the best effective here. That is, it gives 87% yield. Now, I am concluding my presentation by giving the answer of an interesting question, that is, why will you choose DBTMH over other reagent? Actually, there are many reasons for which we can prefer DBTMH. That is, it requires low cost, it is easily manipulable, it requires low possible use of metals, and we know that the metals are actually toxic to our environment. It is water and air tolerant. It requires it can react in solvent free condition in some reaction, and most important is it is applicable to a large types of substrate, providing industrial scale synthesis. So it can be said without any hesitation that this reagent have opened a new door in organic synthesis, where many reactions can be done by DBTMH, and future aspects of this reagent in synthetic research is very bright. Now, these are the references which were helpful to make the presentation. And last but not the least, I want to express my heartful thanks and gratitude to my department to give me the opportunity to present my review work, as well to Dr. Horisadam Ghosh sir to help me to prepare it. Thank you.
Thank you, Kaushik. The next speaker is Samsundar. Are you ready?
Hello, sir. I am audible.
Yeah, you are audible.
Am my screen visible?
Yeah, make it full screen. Okay.
Hello, good afternoon to my respected teachers and my friends. Hello, I am Samsundar Maiti, student of Surendranath College, Sempur. I am going to present my review topic entitled Organic Ammonium Tribromides Mediated Controlled Bromination of Aromatic Compounds. Brominated compounds. Bromine is a chemical element with the symbol Br and atomic number 35. It is the third highest halogen. It is the fuming red-brown liquid at room temperature. Bromine is used for a preparation of bromine compounds. And bromine is used in many such of areas that agricultural chemicals and insecticides and cooling system and air conditioner and hairstyling, batteries and water disinfection, food industry, oil drilling, and many etc. Preparation of brominated compounds. The simplest compound of bromine is hydrogen bromide, HBr. HBr can prepared by distillation of a solution of sodium bromide or potassium bromide with phosphoric acid or sulfuric acid. The reaction is hydrogen gas and with bromine gas at 200 degrees Celsius to 400 degrees Celsius with platinum catalyst. In laboratory, reduction of the bromine with red phosphorus is more practical way and prominent to produce HBr. Anhydrous hydrogen bromide can also be prepared on a small scale by thermolysis of triphenyl phosphonium bromide in refluxing xylene. Bromination of aliphatic compounds. Bromination reactions are crucial in today's chemical industry since the versatility of the form of organotribromides make the suitable building blocks of numerous syntheses. A alkene delocalizes the bromine is color of Br2 dissolved in CCl4 due to the addition of Br2 to give the vicinal dibromide which are colorless. When Br2 reacts with CCl4, there is dipole-induced dipole interaction between molecule and bromide gives Br plus and Br minus, which attacks an electrophilic on alkene and undergoes the electrophilic addition reaction. This is the test of the unsaturation. This addition of the Br2 is alkene is anti-addition. When cis-2-butene is added is Br2 with CCl4, we found the racemic mixture. But when trans-2-butene with Br2 with CCl4, we found the meso product. Problem of using liquid bromine. As a bromine is a very toxic and corrosive as a dangerous for a environment. So problem of using of liquid bromine. Disturbance is genetic materials, malfunctioning of the nervous system, damage to our organs such as a liver, kidneys, lungs, etc. And ethylene bromine causes cancer. Skin inhalation and the brain inhaling the liquid bromine, it may be causes the pulmonary edema. How to solve this problem? As a bromine is a very toxic, corrosive and a dangerous for environment. So is the latent brominating reagents such the ammonium tribromides, such quaternary ammonium tribromides and pyridinium perbromide, which is safer and easier to use. When you exposed to bromine, you should remove your clothes and rapidly wash your entire body with soap and water. When eyes are burning, to use your plain water up 10 to 15 minutes. When your lab, you use the chemically resistant the nitrile gloves and don't use the disposable plastic gloves. Wear eye protection, goggles or face shields. Organic ammonium tribromides. Organic ammonium tribromides are attractive solid brominous and brominating agents. Organic ammonium tribromides, including the pyridine, the hydrobromide, perbromide, are preferable owing to hazards associated with bromine. Some examples of the organic ammonium tribromides. The examples: the tetrabutyl ammonium tribromide and phenyl trimethyl ammonium tribromide, tetramethyl ammonium tribromide. Preparation of organic ammonium tribromide. The tetra-N-methyl ammonium tribromide with reaction with vanadium pentoxide with aqueous hydrogen peroxide, we found the tetrabutyl ammonium tribromide, TBA-TB. Organic ammonium tribromide uses many such areas, photography in plates, papers, films, in pharmaceutical preparation, and also use a biological activity like anti-tumor, antibacterial, and anti-neoplastic. Here the bromination of aromatic compounds using TS and Br2 with any catalyst. For bromination of aromatic compounds, N-N-dibromo paratoluene sulfonamide has been detected a new reagent. It is the first reaction, and at ambient temperature, the reaction penetrates the fulfillment prompting to yield exclusively the corresponding polydominated product. This process is used the various phenols, anisole, and anilines to produce the corresponding polydominated compound as a single product in excellent outcome. And domination of phenol using TSN BR2, we use the acetonitrile 2 millimole and isolated, and we use the 1 millimole of phenol, and with 0.5 millimole of TSN BR2 we found the 40% of 4-bromophenol and 2,4,6 dibromophenol 10%. And when we use 1 millimole of phenol and 1 milli of TSN BR2, and we use 30% of 4-bromophenol and 50% of 2,4,6 dibromophenol. Let us solvent-free methodologies of organic bromination using quaternary ammonium tribromides. Here we try to can see the lot of example can here the different dominating agents and their respective yields. The efficiency of several organic ammonium tribromides were deliberated with several process and organic substrates by solvent-free reaction protocols, including the reaction at evaluated temperature and also under the microwave condition. In short of the reaction will excellent the product yield, and the reaction we undergo the regioselective. Here we aniline the substitute animal, and the product is parabromoaniline. And when we use the TBA-TB, the yield is 75% parabromoaniline. But when we use the TEA-TB, the 68% yield parabromoaniline. But when we use the TMA-TB, the 68% yield. When we use the phenol, the substitute phenol, the product is parabromophenol. When TBA-TB is 72%, the parabromophenol is produced. 64% yield parabromophenol produced. When the bromination of organic substrate, it got a microwave condition. When microwave condition, the aniline treated with TBA-TB, the 83% yield parabromoaniline, and TEA-TB, the 80% yield the parabromoaniline. This etc. Conclusion, here it is the discuss about the brominated compounds, problem of using liquid bromine and benefits of using organic ammonium tribromides, some examples of organic reaction and organic ammonium tribromides. I am thankful to my department to give me the golden opportunity, and to special thanks to my mentor Dr. Horishathun Ghosh sir, partially support for this presentation. Thank you. Hello.
Hello. So with this, the presentation from my group is completed. So next presentation from Dr. Apurva বিশ্বাস, it will start. Apurva.
Krishna will deliver on 13 useful anti-cancer drug.
Sir, am I audible? Hello, sir.
Kisnendo, you are audible.
Okay, sir.
Okay. You share your screen and start presentation quickly.
So just a minute. So good afternoon to all of you. Myself Krishnendu Chatterjee. I am a student of SEM 4. Basically, my topic is cisplatin, which is the most effective and widely used anti-cancer drug. So in my presentation, I will try to describe its introduction, its historical development, its synthesis, and lastly and most importantly, its mechanism part. After my presentation, Tias will continue the remaining. Okay. So as you all know, the cisplatin is the anti-cancer drug, right?
So obviously, I think we should need to know at first the what is cancer in very brief. Okay. Basically, cancer is nothing but the uncontrolled growth of abnormal cells. But the question arises when this situation will occur. Basically, when the normal control mechanism of body stop working, means when the cell cycle is destroyed, then obviously the old cells do not die, but the new cells are still growing. Then there is a situation occur when the abnormal cells growth is uncontrolled, and after that they form a mass of tissues, and gradually it forms tumor, and lastly it is become the cancer. So here I try to show you a pictorial view. Basically, this normal cell to a malignant tumor, this process of formation is called the carcinogenesis. And here I just to try to show you a pictorial view, nothing but. So now the main thing that what is the possible ways to treat a cancer cell? Basically, there are three main possible treatments. First one is surgery. Basically, in this method, the cancer cell is directly removed from the tumor, but it is only possible if the cancer is localized in a position of your body. But it is not so safe because there is a possibility to spread the cancer in the other parts of our body, so it is not safe. The second one is radiation therapy, where the radiation is used to kill a cancer cell, but radiation is not good for our skin, so it has many side effects. And the third one, and the most potential one, which is the chemotherapy. Basically, in chemotherapy, a chemical is used which is called the chemotherapeutic agent, by which we can destroy a cancer cell. And from here, my topic is being started. Basically, it is the cisplatin having two ammonia and two chloride ligand in its cis orientation, having a square panel geometry. Basically, this cisplatin is the first metal-based anti-cancer drug, and it is nearly 90% of testicular cancer. 90% of testicular cancer can be treated with cisplatin. Some cancers like head and neck, in this cancer, it is more efficient, but it is all about all cancer can be treated with it. Okay. So now, if we try to show you that how it will first innovated the first metal-based anti-cancer drug. Basically, in 1844, Mr. Michael Piron, he first described the cisplatin, but at that time it is called as the Piron salt. Then from 1896 to 1920, Alfred Warner, who is the father of coordination chemistry, published many papers on platinum chemistry. And after that, in 1893, Alfred Warner deduced the structure of cisplatin, and it's all like its geometry, their colors, all about. But still, the anti-cancer activity of cisplatin is not discovered. Actually, the anti-cancer activity of cisplatin is discovered by the Bernard Rosenberg. It is very interesting story, and it is also be discovered accidentally, basically. Okay, he is the Mr. Bernard Rosenberg, who is a biophysicist. When he tried to examine a E. coli cell division in an ammonium chloride buffer by an inner platinum electrode, he suddenly noticed that E. coli became appearing wrong. Then he thought that this possibility, this phenomenon is only occurred if the cellular division is restricted. Okay. Then after a long study, he revealed that it is only possible if any chemical is restricted the cell division, and he revealed that the complex which is ejected from the platinum electrode is only responsible for this cellular inhibition. Okay. And he after this phenomenon, this drug cisplatin is tested against many animal tumors, and it get a great success. From here, the success of cisplatin is begun. Now, if I try to show you that how cisplatin can be synthesized in very brief way, basically synthesis can be proposed in many ways, but it is the most efficient way, which in 1970 Dhara proposed. Here, a K2-PTCl4 complex is treated with excess of potassium iodide. Then obviously a tetraiodide complex is formed. Then in this complex, excess of ammonia is added. Then obviously two iodo ligands which are in cis orientation are displaced by two ammonia ligands due to the trans effect. And then this complex is treated with AgNA3, aqueous AgNA3, and a aquated species or aquated complex is formed, and a AgI precipitation is we can get. And this aquated complex, when treated with excess of TCl, then it forms the cisplatin, which is the desirable product. Okay. Now the most important and interesting part of my presentation, which is the mechanism of action of cisplatin. Basically, the actual mechanism that how cisplatin will work inside a cell is not described properly, but there is a proposed mechanism that how cisplatin will work. Basically, cisplatin is introduce his mechanism of action or anti-cancer activity by binding with the DNA. Basically, to a patient, cisplatin will administered by a sterile saline solution. So now I will try to explain you in my way that how cisplatin will work. Basically, this is the cisplatin. When it's enter into the tumor cell, just think it is a tumor cell. When it is enter into the tumor cell, actually in the tumor cell there is a less of chloride concentration. So obviously a water molecule, a chloride ligand will displaced by a water molecule, or both the chloride ligands are displaced by the water molecule, then it form a reactive positively charged species. Then these aquated reactively positively charged species will bind with DNA, and basically it bind with DNA where with the DNA bases. We all know that DNA bases adenine, guanine, cytosine, thymine. Basically, it will bind with the guanine, and on which side? Basically, where the nitrogen is attached of the guanine bases. At that position, the water ligand was displaced by the nitrogen ligand. Then it form a cross-link adduct of guanine cross-link adduct mainly. So it is the adduct. Then if the DNA is not damaged by any way, then it can be repairable. So it is a repaired DNA. But when the DNA is damaged, just like in the tumor cell, the DNA is damaged. So in that cases, DNA will not repairable, then it is cause the cell death or apoptosis. Okay. So now here I will try to show you that how cisplatin can be bind with the DNA, and there is the possible ways that how cisplatin can bind with the DNA bases. Okay. So now it is the DNA structure. Basically it is the phosphate of sugar backbone, and these are the thymine, guanine, cytosine, adenine. They are the DNA bases, and these nitrogens are the binding site where the water molecule of cisplatin is binded, and it produces its anti-cancer activity. If we try to see it in the 3D, it look like, okay. Basically in this position I will try to attach a video, but in that position I think the time is very short, and I have some network issue too much, so it is not possible to at that moment. So lastly I have to end it here. So thank you to all of you for listening me. Thank you to my departmental teachers for giving me this opportunity. Thank you to my mentor Dr. Apurva বিশ্বাস for her guidance and for his guidance, and thank you to all for listening. Thank you, sir. Sir, hello. Hello,
Who is
sir.
next? Who is next?
Yes, ma'am.
Proceed.
Good afternoon to everyone. I am Tiyasha Chatterjee, student of Surendranath College, Chemistry Honors, 4th semester. Today I am going to talk about the topic cisplatin, the most widely spread anti-cancer drug. My friend Krishnendra has already discussed about this. Now,
I will discuss about the treatment of four remarkable parts of our body. The first one is treatment of lung cancer. The second one is treatment of ovarian cancer. And the third one is treatment of testicular cancer. And the last one is treatment of other cancer, basically breast cancer. The first one is use of cisplatin for treatment of lung cancer. One of the most common fatal malignancies is lung cancer. For treatment of non-small cell lung cancer, surgery is used at stage 1 and stage 2 to remove tumors, and after that chemotherapy is used, which is known as adjuvant chemotherapy. The second one is use of cisplatin for treatment of ovarian cancer. The main treatment of ovarian cancer is surgery. And in the next phase, systematic chemotherapeutic treatment is given to the patient to kill very small amount of cancer cells. The third one is use of cisplatin for treatment of testicular cancer. The first treatment for testicular cancer is usually surgery to remove the testicle. Rarely, chemotherapy is given first if the cancer has already spread beyond the testicle when diagnosed. After surgery, chemotherapy or radiation therapy may be recommended. And the last one is use of cisplatin for treatment of other cancer, basically breast cancer. For treatment of breast cancer, cisplatin is very beneficent, which causes enhancement of patient's lifespan. This is all about the use of cisplatin for cancer treatment. Now I move on the next topic, resistance of cisplatin. Here I will discuss four distinct classes of mechanism by which cancer cells become resistant. First one, resistance during dark circulation through bloodstream. The proteins, particularly these have thiol group like human serum albumin and cysteine present in bloodstream, can bind with cisplatin. This protein binding is responsible for deactivation of cisplatin. The next one, resistance during influx or efflux of drug through cell membrane. What is influx or efflux? Movement of ions into cells is called influx, while movement of ions out of the cells is called efflux. Decreased influx and increased efflux of cisplatin cause lower drug accumulation to the cancer cells. The third one, resistance during cisplatin present in cytoplasm. Intracellular inactivation of cisplatin, one of the most important mechanism of cisplatin, which binds with glutathione and metallothioneins. The fourth one is resistance after cisplatin DNA binding. NER is the best way. What is NER? What is the full form of NER? Nucleotide excision repair. It is the best way to remove DNA lesions to induce resistance of cisplatin. MMR protein is very important protein which generally attempts to repair DNA cisplatin lesion. Then I move on the next topic, side effects of cisplatin. Here I will discuss four types of side effects. One, nephrotoxicity. Second one is ototoxicity. The third one is hepatotoxicity, and the last one is gastrointestinal toxicity. First one, nephrotoxicity. What is nephrotoxicity? Nephrotoxicity is one of the most common kidney problems and occurs when your body is exposed to a drug or toxin that causes damage to your kidneys. It can show signs of other types of decreased kidney function, such as decreased urination, swelling from fluid retention, and high blood pressure. The next one, ototoxicity. The first question arises in our mind, what is ototoxicity? Ototoxicity is hearing poisoning that results from exposure to drugs and chemicals that damage the inner ear, often impairing hearing and balance. The next one is hepatotoxicity. Hepatotoxicity from hepatic toxicity implies chemical driven liver damage. excessive use of cisplatin may cause hepatotoxicity. And the last one is gastrointestinal toxicity. What is gastrointestinal toxicity? It includes nausea, vomiting, abdominal pain, and a chemical hepatitis characterized by elevation of liver function enzyme. Now, we can conclude that cisplatin is one of the most potential and effective anti-cancer drug. This resistance and side effects are mainly arises due to binding of cisplatin with proteins and changes in cellular uptake. These are the reference from where I collect all my information. Lastly, I am thankful to my all respected teachers and my mentor, Dr. Apurva Vishwas, and my beloved friends. Thank you so much.
Ma'am, am I audible?
Yes.
Screen is visible?
Yes,
Okay. Good afternoon, my respected teachers, my friends, my seniors and juniors. I am Bujayanta Howladar, a student of Department of Chemistry, Srinath College. Today, I am here to discuss about advances in the development of protein-protein interaction modulators. So what is protein-protein interaction? In short, PPIs. PPIs are the physical contacts of high specificity established between two or more protein molecules as a result of biochemical event seen by interactions that including electrostatic forces, hydrogen bonding, and hydrophobic effect. So let's see what is the challenges in discovering of PPI modulators. The first challenge, the PPI occurs on the interference of a specific domain where two identical or different proteins are in contact. The interference area of the interaction usually reaches 1,500 angstrom to 3,000 angstrom square, which is larger than the receptor ligand contact area, 300 to 1,000 angstrom square. And the interference is highly hydrophobic. The second problem, the PPI interference tends to be flat and contains few groups or pockets, thus making it difficult for designing small molecular compounds to bind. The third problem, the amino acid residues involved in PPIs are either continuous or discontinuous in their respective protein structure. Thus, the result in high affinity binding proteins, making it difficult for smaller molecular compounds to inhibit such high affinity interactions. The fourth problem, compared with traditional drug targets, enzymes or receptors, PPI lack endogenous small molecular ligands for references. Now we will see what is hotspot. The large binding interference are not regarded as the ideal drug targets because it is difficult to find matching molecule. However, the emergence of hotspot makes designing easy for PPI possible. Usually, PPI happens on the several amino acid residues in the interaction region, having critical roles in the interaction. The region of amino acid residues on the PPI interference that contribute to the binding free energy is called hotspot. Now we will see the current approaches for discovering PPI modulators. The first approach, high throughput screening. The high throughput screening, in short, HTS, is a well-established method for discovering classic drug targets. It has been used to identify compounds that target the hotspot of PPI interference. The second approach is fragment-based drug discovery. Fragment-based drug discovery, in short FBDD, aims to identify molecular fragment from fragment libraries. Compared to HTS, FPDD is better approach for PPI modulator designing because PPI interference often consists of many hotspots. SPR, NMR, mass spectroscopy can be utilized for discovery and validation of fragment hits. The third approach, structure-based design. Since the PPI's lack of endogenous small molecular ligands, it is challenging to rationally design associated PPI modulators. At present, two designs are available for structure-based design. The first, based on hotspot structure,
The second one is peptidometric design. The last approach, virtual screening. The virtual screening is based on professional application software to screen out hits from compound libraries. So what is the mechanism of PPI modulators? The small molecular or PPI modulators can interact not only with protein-protein interaction, but also with allosteric sites. Study shows that the small molecular modulators can either bind to non-interaction region of proteins, which is named allosteric inhibition, or bind to PPI interference, which is named orthosteric inhibition. Beside the PPI inhibition, some modulators can stabilize or even enhance PPI. I'm thankful to all of the teachers of my department, especially my mentor, Dr. Apurva sir, and also thankful to my friends to help me out to complete this presentation. Actually, this is the first part of my presentation. The last part will be discussed by my friend Shomik. So that's it all for today. Thank you.
Yes. Yes. Visible? Yes. Hello.
Yes, it
Hello.
is. It is.
Yes. Okay. Basically, PPI modulator development. This is the second part of a talk that will be previously discussed by Ojanta. Here, the discussions is generally a start by the what the type of the PPI modulators. Generally, there are three types of PPI modulators are there, like the small molecules, like the peptides and the antibodies. In case of the classical drug development strategies, where actually their targets generally the catalyst, their targets, and the targeting surface of the specific molecule is really flat, and the surface here are quite large. That's why the the uh, the target that target strategy is not so much fantastic to develop a new kind of drug. So the small molecules modulators is then molecules where actually the target is that the narrow and the tight of the interface of the molecules. Then the monoclonal antibody. Monoclonal antibody is a small molecules that is generally designed for covering the whole surface area of the PPI modulators. Why it's so? Because the because the monoclonal antibody has some specific characteristics features. It, it has a high specific it has a high specific site to target the specific site of the PPI, and it also regulates some of uh, metabolic mechanisms of our bodies. And the last is the peptides. Peptides modulators. It is as an it's so much. It has so much specific site because it has a balanced characteristics features versus the balanced characteristics features because it has a high specificity and it directly interact with the specific surface of the PPI. Next is the what's the surfaces of the PPIs. PPIs surfaces mainly had the two types of surfaces are generally discussed in here, like the MD2, P53, and next will be the PCL and box. What is P53? P53 is then one kind of is a one kind of proteins that daily regulate the cell cycles, and it has a specific characteristics role for for suppressing the the what is MD2? This is an one kind of proto-oncogenes that that some of surrounding features, this such a specific gene actually mutated to an horrible mutant variants that is so much dangerous for our bodies to generate cancers. So in an it is shown that genes actually convert to an p53 genes, and that's why the actual characteristic features of the p50 genes proteins functions is going to be dissolved, and that's why it cannot be functioned for suppressing the tumors. So our main focus is to just to develop a method that prevent the binding between two components. Means first is the p53 proteins and the MD2 proteins, and this is our own main focus strategies, and this is our own main focus method to develop the modulators. And here the protein structures are being shown in here. Actually, the kinds of proteins are that bind to interact to the surface of the p53 and MD3, and in this way they are can to participate to develop a horrible disease. Our main focus is that to just develop the method to prevent such bindings that so express their own actual function to suppress cells expressions. Next is the actual crystallographic structures of the previously discussed MD2 and p53 genes. This is the X-ray crystallographic structures where actually notice that there are some kinds of protein molecules, and this is the X-ray crystallographic structure where the alpha helix of the p53 proteins, the molecules are present, and in the central point, the MD2. This is an one pocket-like structures is present where we want to establish some kind of modulators that can separate their own activities. Here, the computer-based, software-based characteristics features, characteristics structures of these two particular suppressors. Next is the what's the chemical structures of these MD2 p53 modulators. Here, the actual structures developed by scientists like the nuclein. Nucleins, here are some variant on theirs. They are the most crucial, used, most helpful uh, used for this kind of modulator. This is the nuclein tree. Why nuclein tree is developed for this purpose? Is because it has some specific characteristics features. What's the specific characteristics features? In an nuclein first and second compound, uh, in there are some of the shortage of their molecular specificity and some kind of their binding inhibition characteristics features, and they have some lack of characteristics features are lost on theirs. But scientists develop nuclear in such a way they are just replaced the replace the three sons of the imidazole rings and where this methoxy groups, and also they develop a new kind of group that are attached in specific of this nuclein tree, that is the tarbutyl group. Why it is? Because it inactivates the imidazole rings and the benzyl rings in case of some metabolic characteristics prevention method. Means some metabolic reasons on theirs that prevent these imidazole rings and benzyl rings. If we just discuss in a microscopic view, microscopic point of view, we can be easily understood what's the actual things are going on there. Next is the second kind of suppressors. second type of suppressor is the BCL and BX. This BCL and BAX, these are one kind of protein molecules. Where the BCL is done anti-apoptotic proteins, where the BAX is done pro-apoptotic proteins. When a box apoptotic proteins are going to attach to an BCL protein site, and they are just play in an reversible function to each other, and that's why the function is going to be reduced. Here, the some of pictures are given here. This is a pro-apoptotic proteins binding sites, and this is the anti-apoptotic proteins binding sites, and their corresponding proteins are described as. Here, small molecules is noticed. This is the one kind of modulators that interact with both protein tertiary structures with an DNA helix. And if we just visualize this in a manner that's help us to understand what's the actual function played by a specific modulators. Here the X-ray crystallographic structures are described. Here actually is an X-ray crystallographic structures of the BCL protein, and here the 6 or 5 they had 4-week alpha structure of the corresponding BCL3 protein, and here the pocket-like mediate structures in here. Our main focus is that to develop the method that mimics the specific hotspot in means the binding site uh, between the box and the BCL, and that help us to develop a new method to resolve so many health related problems, like some of horrible diseases may be controlled by these methods. Our main focus is that to reduce this bond between the BCL and the box proteins. And the next is the chemical structures of these corresponding BCL and the box proteins. Here the new kind of methodologies are developed by the scientists for the chemical structures to be shown in it's actually developed by the spectroscopy here, where actually develop a new method. Here actually is found that modified some of the previously applied compound 2 by highly effective compound 3. Here the reason is that to develop this compound 3 is that this compound has an high affinity to resolve in our human serum. That's why this type of compounds that we develop. We are not to discuss so many of such compound characteristics that will be some of more like feelings. So next is the what is the stabilizers of the PPI. Stabilizers PPIs means when we develop the new kinds of modulators, it must be fitted. It must be fitted to our own specific site of this disease. Otherwise, it may be create some of head-like problem. So what is the stabilizers? The past reported stabilizer is the fusicosin. This is the one kind of natural product, and it acts between the 14-3 proteins and the and some of and a specific complex like the 5-8 rings of the 5-8 ring of the hydrophobic region of an compound that is visible in here. Actually, this fusicosin A, this interact between a 5-8 ring compound with an 14-3 proteins, and it play and crucial roles to stop the mitotic cell division in case of the cancer cell advancement. Next is the pyrrolidine derivatives. Pyrrolidine derivatives is uh, is an stabilizers that generally act between the 14-3 and plasma serum membrane. and here hand it's play a crucial role to stop the apoptosis and also the cell proliferation, sorry, and also help in the cell division in case of the when a modulator is going to be developed. Next is the paclitaxel. Paclitaxel is then microtubule stabilizers. What is microtubule stabilizers? Microtubules is then small cell molecules that's generally placed in a cell inside the nucleus that just been developed. What is it? It actually binds the beta tubulins and then it promotes the function of the microtubules, and that's why a stabilizing activity is to be formed. And the last is the is amidolite. Amidolite and it then 20 members, then 20 member cyclic rings natural product. It's generally isolated from an cis bond, and it's play a crucial role to prevent the mitosis and cell proliferations in a microtubules. So the lastly the conclusions. Actually, the PPI modulators development is then one of the most fascinating and one of the most challenging because by the lack of unavailability of the quaternary structures of the proteins means so much computer-based design is not be developed in a manner. That's why it's help us to develop a new kind of graph. And the second is that some of preclinical and clinical studies shows that some of these advantages are sourced that play a long time activity in our body. That's why some of places the PPI modulator activity is quite some of these advantages. But I think it has a potential role to develop a new kind of drug that's help us to resolve so many horrible diseases like the cancers, tumor proliferations, and also the heart diseases. It can be. Yep. This is a reference where I am just put my topics, and I am also so much thankful for this types of books that helped me so much. It's the Donald White and the Sir Samuel's books. And I'm so much grateful to all of my departmental teachers, and I'm especially thankful to my mentor, Dr. Apu Research sir, and also thankful to my friend that helped us and also motive me to present such a such a reliable expressions of my work. Thank you, sir. Thank you, everybody.
Hello. I think Apurva. I think Somik is the last one.
প্রবলেমের জন্য কানেক্ট করতে পারছেন না। হ্যাঁ, আর কেউ কি বাকি আছেন left?
না স্যার আর নেই।
আচ্ছা, ঠিক আছে। তাহলে আজ এখানেই শেষ করি আমরা নাকি? এটা সেন প্রোগ্রাম। আবার আমরা 28 তারিখ আসবো সেম টু স্টুডেন্টদের সেমিনার নিয়ে, সেটাও সম্ভবত এই 3টে থেকে 5:30 বা 6টা এরকম স্লটেই হবে। হ্যাঁ, তাহলে টিল দেন গুড বাই আর কি, তাই তো?
So this is the end of the meeting.